All right, now here's another one that should be reviewed, but I want to make sure that we remember what's going on. Difference of perfect squares. Okay, the difference of perfect squares. Now, everything you need to look for is in its name. The difference, so there should be a minus sign in between the terms. It's just two terms, and they must be perfect squares. Now, we still need to start the process by looking for a GCF between the two numbers, because sometimes there will be, but sometimes there's not. So, if we look at number 7 there, 121b squared minus 81. 121 and 81 do not have a GCF. The reason why I know that is because I know that 121 and 81 are both perfect squares already. So let's just jump into our difference of perfect squares factoring. It does factor into two sets of parentheses. Even though it's two terms, we still have two sets of parentheses. Okay. 11 squared gives us 121. So 11b times 11b. 9 times 9 gives us 81. And what do we do with our signs on the difference of perfect squares? One is positive, one is negative. The reason for that is because the outside and the inside are going to cancel. Every single time, that's what we need to happen. We need those to cancel so that we just have 11b times 11b, which is 121b squared, and positive 9 times negative 9, which is 81, negative 81. Okay, that's it. All right, number 8. Is number 8 the difference of perfect squares? No, it's not. They are perfect squares. There's only two terms, but there's a plus sign in between. So this is not factorable. Not factorable. You got to look out for stuff like that. Do what? Yep, if it is a plus sign right there, it is not factorable. If you have perfect squares, but there's a plus, not factorable. Okay? Because, let's think about it for a second, if we tried to factor it, because a lot of you still will, don't write this down, I just want you to watch. If you tried to factor this, 3 times 3 is 9, b times b is b squared, to get the positive b squared, both of these would have to be a plus. And what happens? We would end up with a 6b in the middle. Okay, we didn't have a 6b to start with, so this does not work for this one. Okay, it must be the difference of perfect squares. Okay, let's look at number 9. 486p squared minus 6. Now, we got two terms, we got a minus sign in between, but 486 and 6 are not perfect squares. They're not on our list of perfect squares over here. We cannot square a whole number and get 486 and 6. So that means we must start with a GCF. I would think that it's 6. Is 486 divisible by 6? It is. Okay, so if we start by taking out a 6, we're left with 81p squared minus 1. 81 and 1 are both perfect squares. So this is 9p plus 1 times 9p minus 1. Because 1 squared is 1. 1 is a perfect everything. A perfect square, a perfect cube, a perfect fourth, etc., etc. Okay, we can also do this with multiple variables. Okay, we can do this with multiple variables, x squared and y squared. Same principle applies. We still need to look for GCF first. 50 and 18, they're both divisible by 2. They both don't have an x, they both don't have a y, so we just have a numerical GCF here. So when we factor out the 2, we're left with 25x squared minus 9y squared. Now we have the difference of perfect squares. Two terms, minus sign in between, 25 and 9 are both perfect squares. So 5x plus 3y, 5x minus 3y. All right, questions? There's another perfect square scenario that we can look at. Perfect square trinomials. Perfect square trinomials. So a trinomial has 3 terms. So we're looking for 3 terms. Perfect squares for the first and the last. Okay, perfect squares for the first and the last for it to be a perfect square trinomial. So if we look at number 11, we have 64 minus 112m plus 49m squared. Now, a lot of you probably want to put that in standard form, and you can. I'm going to do it the way that it is. Okay, I'm going to factor it the way that it is. So we have 3 terms. 64 is a perfect square. 49m squared is a perfect square. So this is a perfect square trinomial. Let's factor it. Okay, 64 is 8 times 8. 49 is 7m times 7m. 112 was negative, so both of these are going to be a minus. Check it. Okay, the outside gives us negative 56, the inside gives us negative 56, and negative 56 plus negative 56 is negative 112. Now, here's the deal with perfect square trinomials. Are these the exact same factor? Yes. So we have to write it like this. 8 minus 7m squared. That is your final answer. And yes, you have to write it with the squared. Yes, sir. I do not know the answer to that question, to be honest. I guess we'll find out. I wouldn't do it. I would put it in as squared because I want you to be in the habit of recognizing that anyway. Okay, number 12, 245m squared minus 210m plus 45. Perfect squares? Nope, not yet. Do we have a GCF? Yes, they're all divisible by 5 because they all end in 5 or 0. So let's take out a 5 first. Oh, goodness, what is that? That's 49? Yeah. 49m squared minus 42m plus 9. Yeah. All right. So now we have perfect squares, right? 7 times 7, 3 times 3, minus and minus. Check it. Outside's negative 21, inside's negative 21. Those two together give us negative 42. So this is 5 times 7m minus 3 squared. The 5 is not squared, but the 7m minus 3 is squared. Okay. Let's do 13. Okay, we can also do this with 2 variables. 112x squared minus 280xy plus 175y squared. So not perfect squares at the moment, right? So let's see here. Do we have a GCF? I'm thinking, are they divisible by 3? Maybe? Nope. Y'all find out what those are divisible by. All right. What's the GCF? You think it's 4? Is it 4? Thank you. Somebody did what I asked them to do when I answered the phone. Oh, well, thank you for the honesty. Oh, not 4. Are they all even? No, okay. All right. How about 6? Nope. 7. It's not 10. 7? It's 7. I think. Check. Yep, it's 7. Okay. So it is 7. Let's take that out. So we take out a 7. We are left with 16x squared minus 40xy plus 25y squared. perfect squares. This is a perfect square trinomial. 4x. Oh, it's another minus. Now, I know all of these examples have been minuses, but they aren't always. Okay, they are not always minuses. If that 40xy had been positive, then they'd both be pluses. Okay, check it real quick. Outside and inside both give us 20x, negative 20xy, so those together give us the negative 40xy. So 7 times 4x minus 5y squared. Okay, two more. 14 and 15. Number 14, what's going on number 14? What do we call that? Two terms minus perfect squares. So it's called the difference of perfect squares. It's just our perfect square here has a higher power. It just has a higher power. So 11k squared. When we square k squared, we get k to the fourth. So 11k squared plus 7, 11k squared minus 7 is how number 14 factors. Okay, same deal with number 15. Okay, 49 and 64 are perfect squares. We've got r to the fourth and r squared for the middle. So this is a perfect square trinomial. This is 7r plus 8. Excuse me, 7r squared plus 8 squared. Is how that factors.